And I want to give a shout out. Mark Madison's in the room. I would not be standing here if it wasn't for Mark. He was my cohort in crime in 1990 when we proposed the very, very first project, which really, before the word phytoremediation existed, it was the Lakeside landfill in Beaverton, Oregon. It was against the law. The regulator, DEQ, came out to rip it out with a little bit of explanation. They've left it. It is now the final closure plan, and the landfill is now closed. But that was 1990. It's amazing to be standing here after all that amount of time. And I do believe that Oregon, Pacific Northwest, does have some major advantages, and I appreciate the fact that we're talking about markets. So we're going to talk about small towns. I think that, like I said this morning, the low-hanging fruit of ongoing, not remediation, but phytotreatment is small communities. The criteria for success, the phyto-attached growth reactor, ag nonpoint, and it is the news. It is in the news in Iowa every day. Water treatment, Gulf hypoxia, nitrate, lawsuits going on, $5 billion to clean the Nonpoint Nitrate pollution. We're talking serious money. And there's not denial like it was 20 years ago when basically there was poor data. The farmer groups really kept us from getting data. We're past denial. We're actually trying to figure out what to do about it. And this morning we talked about the over 10,000 towns. Iowa has 450 of these towns. Some of them are not very successful these days as they're having to spend more resources than their few people provide, and there's kind of a migration to the jobs in the cities. So we have often an opportunity. So our big idea still is that for phyto to work, every drop of water passes within the thickness of your finger from a root, hopefully multiple times before it seeps away, before it hits a drain or percolates. And this is my hometown, Loudon, Iowa. It's 800 people. That's my farm, as it turns out, the place I grew up, a 100-year-old farm. The wastewater treatment system is right here, surrounded by corn and soybean country. 3 years ago, the land was worth about $12,000 an acre. Right now, it's about $9,000, and I wish it was back to $12,000. I wish the price of corn was $1 a bushel more. I actually am farming on halves my farm. We're trying to make that farm a zero-discharge farm, no particles, no nitrate, and do it profitably. It is impossible. I'm telling you right now, it is really hard. In Loudon, they have a small trickling filter water treatment plant built in 1957, and we put trees there irrigated with secondary effluent out of a clarifier in 2011. We have this device. It was called the Phyto Test Cell. I believed we needed the ability to have growing plants in intimate contact with different media so we can see what had the better treatment capacity. You can use this idea. We've used it. And ultimately, we used local soils, different kinds, and we had a dose which was about a 3-day residence time. And here's a clarifier. Here's the trees right next to it. And we would manually dose the water, and it would trickle into the perimeter drain there. And this was the early data. So here is the influence of ammonia. It's not very high. It was the growing season. It was still warm enough. But this is the ammonia concentration coming out of various soils. It was below detection. And the bottom line, ammonia is what is the primary violator for most of these communities in their discharges, especially in the cold winter season. This is E. coli. We had that also analyzed by the state lab. This is inlet, and this is logarithmic scale. This is outlet. Here's some alluvial soil, not so good. This is vermiculite, perlite. No organic carbon in the basic media, no inoculation, if you will. And this is very interesting because there is a potential that we can get away from chlorinated or UV disinfection if we can do this correctly. But this is early data. One of, and it was what it was. So ultimately, what we're proposing is that we use phyto behind existing systems in small town Iowa that is a supplement to whatever they're doing. And normally it's oxidation ditches, sand filtration beds, lagoons, a little bit of trickling filters. This is in Coupeville. And the Coupeville Washington trial started in 2011, and we were able to get 3 different soils, 5 trees each, and we connected it to the, after the UV disinfection, we put water through it, dosed on a regular schedule, so we had between probably trying to get a 2-day dwell time in this water. And this is that early data. This is nitrate nitrogen. This is in trees that were 2 years old, or 3 years old, I believe. And here's the test cell with sandy soil, compost, perlite, a little more there. But ultimately, this is nitrate removal. Nitrate is hard to get out of water. It really is. And it is a real problem when nitrate is the basic element or basic compound the Des Moines water treatment system lawsuit is built around. Nitrate comes out of primarily tile lines in Iowa agriculture. This is nitrate nitrogen also. We planted these trees in May of 2011. This is influent. This is 2011 and a little bit later, 2012. But you can see we're getting pretty good nitrate removal in this, especially by year 12, in different kinds of media. And this is what the 28-month-old trees look like. Here's the oxidation ditch. And ultimately, this picture was taken by Kent. In the dormant season, this is the influent. We're still able to get nitrogen removal even in dormancy. Now that's an interesting thought, because it is in the winter months, the cold weather months, that things like anaerobic lagoons or aerobic lagoons fail. They cannot get the oxygen out. Sometimes they even freeze over in the upper Midwest. And to actually have a system that has enough carbon, enough microbial activity that you can still get treatment in the dormant season is really an important feature here. We like poplar. This morning we were talking about reasons we like poplar. But one of the reasons that I really like poplar is that you can cut it off and it grows back from the cut stump. So that gives me perennial roots and root activity, but it gets me both for management reasons and for harvest value, it gets me a shorter rotation on the crop. If it's a fuel crop, that could be good, but definitely it makes it such that I don't have to have 80-foot trees treating water. I can use shorter plants, and this is going to come in to the next idea we're going to propose. We've taken this to the level of several research publications. Hayden Auslan. Hayden is an Oregon State biological ecological engineering grad. He did his master's at Iowa, and he basically built, based on test cells and soil from the Port of Morrow, Oregon, the ability to control the temperature in dormancy. And again, these were his results. This is for ammonia nitrogen. This was feeding a synthetic potato processing wastewater that they could control. This was the water going in, and under different soil blends, this is the average of a whole set of sampling. But you can see a significant amount of removal, and it's actually often and normally below the discharge standards for small Iowa communities. This is the Port of Morrow. We looked at the Port of Morrow for using land application and treatment to remove nitrogen. They have a lot of nitrogen. They have 5,000 pounds of nitrogen in their wastewater a day. And very little nitrate. They have ammonia and protein, amino nitrogen. This is what their average lagoon water from their potato processing plant. And at the time we were there, it was about 5 million gallons a day. I think they're expecting it to be around 7 million gallons a day. They do principally land application, and that is still their strategy. But we use test cells, and this is the root system that you can make very quickly in one of these test cells. So when you talk about the strategy being close flow of water and contaminants to a root, this thing is a tortuous path of water going through that type of a cell system. And this was early data. We planted the trees in May, and then this is July, the first growing season, and this is the water quality at sampling events going in, and this is the water quality. We have different things. We have manure blended with soil, sawdust, perlite alone. Ultimately, here's the dormance period, and they all converged such that it was actually the root activity that became the primary pollutant removal mechanism, and everything started to converge, and it was doing it in a time of dormancy. There's no active growth, and yet there's still treatment. A lot of it is adsorption, and frankly, then it oxidizes, and nitrate can still move. But this was going in, and this was the removal of going in and coming out of different groups of test cells over a period of time. So this is good news if your pollutant of concern is ammonia. It looks like you get adsorption, we would expect that, and then there may be some treatment going on. So I've been long thinking of how is it that we get phyto behind towns, because as many of you know, I talked to Tim about this, he does Willow. We cannot seem to get the regulators to accept the idea of putting trees behind a small town and then put the water into those trees and let it go. It's like, putting the water out into the wild. And this has been happening ever since we've started proposing this. So we have this phyto-attached growth reactor, and this is basically an expanded test cell. It's 4 foot by 4 foot by 4 foot, 4 foot deep, and so 30 trees each. This is what they look like. You can buy these bags of perlite. They make them in Oregon, just right near the Columbia River. And it's a perlite bag, and you put the trees in, and ultimately this fills the bag with roots. 2 minutes left? How many minutes did I get? 50. Oh, wow. Okay. Well, this is going to change. So much for. Okay, but ultimately, whoops. Okay, so we believe we can get about 250 gallons per day through one of these things, and get the pathogens and the ammonia. And so you then therefore combine them into enough cells. You have a filter, a instrumentation, connect that to a computer on the in and the out. You can control it, and you dose this bag and get the underflow, and when it's done, it's done. And we're proposing to put these in large fabric buildings made by FarmTech, and for winter treatment. And this is winter treatment. We don't really care about summer. It's being done quite adequately with the lagoons. This is for winter treatment. And we're beyond ammonia and pathogens. This is caffeine, but all those industrials, you saw us talk about that routinely. We think there's scalability. We think it can fit uniquely behind dairies, hospitals, veterinary clinics, what else, where there's actually point sources of some of these extreme contaminants of concern. So back to Loudon, we would like to do some demonstrations. And it builds on, again, the whole thing. We've learned a lot about stormwater. Here's up in Coupeville. We have a stormwater treatment system. This is a different way in that we took roots And we've laid them laterally over top of a drain that's coated with root guard, and we capture the first inch runoff event and seep it through the profile. And here it is, planted, and the water ponds and drains. And one piece of data, this is nitrate nitrogen. This was after we planted it. You know, in is 500, 340, 70, 60. Here the trees broke bud, and we haven't had nitrate breakthrough again. We've been doing this for quite a while. I don't want to waste time here, but, well, I do. Here is our original proposal. My doctoral work was back in '88, where we put trees to intercept groundwater, and you can see here's the groundwater from upgradient, and 2 rows of trees in, the nitrate plummets. And what we're proposing is that we take these drain lines that are currently putting nitrate into the stream, and they have now a tile interception valve. They put the drain lines parallel and run this water through the system, through the riparian area, intercepting it by tree roots, and the tree roots ultimately are the carbon for the denitrification. And these saturated buffers, as they're called, they run out of carbon, so you don't get the nitrate removal. Here's your carbon pump. So that's that idea of phyto being a carbon pump by design. And in Oregon, this is the kind of roots you can grow in the first growing season. You can get that root down there reliably. Whoops. And ultimately, this is called polaring. You can cut the tree off and it grows back from the stem. Well, that's interesting in that if you plant these in Iowa riparian zones, the farmers do not want shade on their corn crop. So we believe that actually we can grow buffers and then manage their height to reduce the negativity and ideally change the regulations so you get a government buffer set aside, or funding for a single or 2-row buffer. Right now it has to be it'd be looking like this, but probably shorter. And so, 2 roads diverged in the poplar wood. This was the project that we did back in 1990, Mark and I and the people at CH2M, and this was 7 years later. It changes the whole ecosystem where this is done. It changes subsurface and above surface. It looks different. It's manageable by people that do not need PhDs in poplar. It's able to be maintained by people who are gardeners and farmers. With slightly modified equipment, we might be able to make it into a harvestable crop as part of the routine maintenance. And we are in the year of the Model T. Imagine what this will look like when it's a Corvette. When we put in focused effort, and I think my goal, I have 10 good years left, I think, my goal is that you would want phyto first unless you couldn't have phyto. Right now we're kind of a weak thought that comes in late. I think what we hope for is that people, thanks to publicity and data and good news, that you would want phyto first, especially for these small communities, unless you couldn't have phyto. And so that's the direction we're heading. I invite anybody here to help us find projects. We want to do 4 prototypes this year. Our goal is in 5 years to be able to do 25 communities of 100,000 gallons a day or more. And that's it.